Hey guys, welcome to my channel. I'm leetcode. If you guys are new to my channel, I pretty much do legal style questions and I explain things in the simplest way possible. Today we have a very interesting problem, guys. I really like this problem. This is a very good introductory to solving sliding window problems, right? So it's a very good technique to put in your tool bag so you're able to solve all the problems just like it, okay? So let's go ahead and read the problem statement. So it says the problem is called max subarray of size k, right? So pretty much it says given an array of integers of size n, right, and a number k, return the maximum sum of a subarray of size k, right? Okay. All right. So pretty much subarray is pretty much an array, a subarray inside of the array, right? Pretty much sequence of numbers of a yeah. So right now this is a subarray, right? Right, so pretty much we're given so for this particular example, right, they said the subarray that they want, right, they said find the maximum sum for a subarray that exists in this array, right, of size 2, right? So pretty much the subarrays of size 2 in that array are 100 and 200, right? That's a subarray of size 2, right? They're right next to each other, subarray. Another subarray is 200 and 300, right? Another subarray is 300 and 400, right? That gives you 700, guys. So I hope you guys were able to get that, on what a subarray is, right? So that's very important. So now that we know what a subarray is, right? So pretty much, we need to find the maximum sum, right? So we need to, so this for this subarray, the sum is 300. All right. For this subarray, the sum is 500. But for this subarray, the sum is 700. So the maximum subarray, right? Sum for a particular subarray is 700, guys. So that's perfect. So that's why we return 700, right? This one, they want a subarray of size 4, right? And that's pretty much the whole array. So pretty much, we return the whole array, right? Which is 1,000. Pretty simple, right? So the easiest way of solving this problem, guys, will be to generate every possible subarray, right? Have two for loops, right? One that's linear that loops through the array, right? Another one that loops through at every iteration, right? We loop through up to a k distance apart from it, right? So that will cost us n times k, right? It's not too good, Imagine if you had like 1,000 numbers and k was 100, right? That means we will loop through the same numbers over and over and over again, right? We don't want to do that, guys. We want to save space. We want to save, no, not space. We want to save time, guys, because we keep doing that over and over again. That's not efficient at all. I'm saying there's a better way to do it, right? We could apply the sliding window technique to solve this problem, guys. It's a very efficient way to. It's going to help us bring down the time complexity, guys, to O of n, right? Pretty much reduce the time complexity, guys. So it's a lot better. So I'm gonna go through an example with you guys really quickly, okay? Hey guys, those are pretty much the examples given to us, right? So I just put it in there for simplicity, guys. Just to show you guys the thought process, how we're gonna approach it with the sliding window, okay? So the sliding window, how it works, right? So so we have 2 pointers, right? A left and a right pointer, right? So the left pointer, right, is gonna, pretty much point at the beginning of the window, and then the right pointer, right, is gonna expand the window for us, right? So we're gonna keep expanding, right? And then once we reach a certain size, right? So pretty much, yeah, I forgot to say. So as we're expanding, right, we're gonna keep updating the sum variable, right? All the numbers that are included in the window, the current window that we're at, right? We're gonna add it to the sum, right? They're all gonna be accounted for by being because we're gonna update the sum with their values, right? So, and then the maximum sum, right, is pretty much gonna keep the maximum sum that we've seen so far, guys. You know what I'm saying? So now, once the window has reached, like, the capacity, right, the length, right, of a particular, like, whatever k, the length k, right? Once it has reached that, we compare it, right? We compare this sum with the maximum sum we've seen so far, and then not only that we do that, we also need to shrink the window now, right? To shrink it, we just gonna update, move the left pointer to go into the next number to shrink it back to fit the constraint, right? So, and then before we move it forward, right, we need to subtract that number from the running sum, right? Because we're not accounting for it anymore, so we need to remove it. So that's the whole point of us doing that, right? So let's just go through an example really quickly, okay? So we get the left pointer and the right pointer pointing at the same element at first, right? So now what we're gonna end up doing, guys, so we check, right? So right now they're both pointing at the same time, right? So to account for 100, right, we need to add it to the sum variable, right? So the sum variable gets updated, right? And then now we need to increment the right pointer, right? Okay, we increment the right pointer, right? So now, but at every iteration, guys, I told you guys we're gonna check has the window reached the capacity yet. If it reached capacity, that's where we do the comparison, right? So when it was at 0, it was of size 1, right? So it wasn't equal to k yet, so we were still good. So now, right, once we're at 200, I told you guys we always add, whatever number right's pointing at, right? We're accounting for 200. So now the window sum, right, of the numbers is equal to 300, right? So now, since we got 300, guys, we check, right? We check. So I told you every iteration, right? We check. Is the window reach capacity? Yes. It's exactly of size k, right? Since it is exactly of size k, we're going to compare that sum with the maximum sum, right? So we check which one's bigger, 300 or 0. 300 is bigger, right? So the maximum sum gets updated to 300, right? And then, guys, we need to shrink the window now, right? For the next iteration, guys, we need to shrink the window. So since it is bigger, right? The way we have to shrink it. So we would just increment the left pointer to go into the next number to shrink it, right? But before we do that, right, we need to subtract whatever number the left pointer is pointing at, right? Since we're not accounting for it anymore, we need to subtract whatever number that the left pointer is. So before we move forward, right, and not worry about that number anymore, we need to subtract it. We subtract it from that, right? And then now the thing's 200, right? And then we're allowed to move the left pointer to go into that element, right? All right, so now the right gets incremented, right? And the left pointer is pointing at 200, right? So now we do the same thing, guys. We add 200 plus 300, right? We add 300 to the running sum, right? To the window sum. Now we have 500, and then this is the size size k, right? It's times 2. So we check again, right? 500 or 300, right? 500 is bigger. So now we do the same thing. We just keep going forward, guys. What I'm saying. So we need to subtract 200 since we want to shrink the window now, right? So it fits into the constraint, right? Because the constraint says it needs to be of size k, right? Not greater. Okay. So now the sum now is 300, right? So now the left gets incremented again, right? And then the right gets incremented, right? And we do the same thing again, guys. Same thing, right? So we check. We check 3. So we add 400 to it, right? Since the right increment to account for the 400, we increment that. So let's go to 700, right? So now we check 700 or 500, right? 700 is bigger, and then we're good. And then that's how the whole thing works, guys. I'm saying. So pretty much the left pointer is going to help us shrink the window. The right pointer, right, is going to help us increment the window, right? So this is a static sliding window. I'm saying there's a dynamic sliding window when yeah. So there's a little variation, guys. So I'm saying. So yeah, let's go ahead and solve example 2 really quickly. So we have the left and the right putting at the same element, right? So now this says the subarray should be of size 4, right? So yeah. So let's continue, right? So right now we are counting for 100. We add 100 to it, right? So now the sum's 100. And then now we increment the right pointer, right? So the right pointer gets incremented, right? All right, so the window is, yeah, before we do that, we need to, 200, right? So now that's the running sum 300. So now we check, right? Has it reached capacity yet, right? Is it a size 4 yet? Nope, it's not. So we keep incrementing, right? So boom, 300 plus 300. So we keep adding to the running sum, right? To the window sum. So it's now 600, right? So now we check, is it capacity yet, right? Is it of size k yet? Nope. Increment it again, right? Keep expanding it, right? So now we check. So before we do that, we add it, we account for it, right? 400. Now we have 1,000. Has it reached capacity yet? Yes, it has reached capacity, guys. We're set. So now the maximums gets updated to, we check the 1,000 versus 0. 1,000 is bigger, so we get the maximum sum, right? So that's how we got that solution, guys. I'm saying. So yeah, guys, I hope I was able to clear any doubts. Hopefully you guys understand how helpful the sliding window can be, right? So this technique can be used in so many different problems, guys, and that's why I'm trying to teach it to you guys. You guys are able to solve all the problems like it. So let's go ahead and jump into the code, right? All right. So right now, like I promised you guys, we told you guys we got a left pointer, right? So we got a left pointer, right? Starting at 0, and then we got a right pointer as well, right? It also starts at 0, right? And then we have the sum that's gonna keep track of the window sum, the running sum that we have so far, right? And then we have a max sum, guys, that's equal to 0 as well, right? So now we're gonna have the right pointer, right? So the right's job is to expand the window, guys. Expand the window for us, right? So right is less than the array n, right? N is just the length of the array, right? So now we increment right plus plus, right? So going. So now every iteration, guys, I told you guys we're gonna update the sum variable to equal whatever number. So the right's pointing, right? So to account for it, so the right is expanding, right? So now to account for a number, we also remember that we use the right pointer, right? So we do right, so we get the number, right? So we would get first right is equal to 0, so it would be 100, right? So we account for 100, so we add it to it, right? So now, guys, after we have that, the next thing we do, we check, right? If the right minus left, right, is it greater or equal to k, right? Is it of size k, right? If it is of size k, right, we need to do something important, right? So we need to check the maximum sum, right? So we're gonna get the maximum out of the two. So the maximum sum so far, or the current running sum that we have, right? And then after we do that, guys, what I'm saying, we need to pretty much, right, we're gonna pretty much subtract, right? Because we need to shrink the window now, right? So we need to shrink it. So to simulate the shrinkage, right, we need to subtract whatever number the left pointer is pointing at, right? So the way we do that, right, we do sum minus whatever number the left pointer is pointing at, right? Right? So now after we do that, guys, what I'm saying, since we not accounted for it anymore, we subtract it from the running sum, we can increment the left pointer. All right, so now we're pretty much set, guys. We just return the max sum. All right, let's check and see if we pass all the small test case. All right, that looks good. Let's check if we pass all the test cases. Perfect, guys. We're able to pass all the test cases, guys. And I want to thank you guys for taking the time to watch this video. If you guys are new here, make sure to subscribe because I'm going to do other videos just like this one, right? And yeah, thank you guys for watching, and I'll see you guys in the next one.